first question of exercise 2.1, and the question is, which of the following are sets? And to justify our answer. So before going into the question, what is a set? A group of observations is defined as a set when everyone in this world gives the same answer. It is a basic definition. So for example, if you ask anyone in the world what is a set of natural numbers, everyone would say 1, 2, 3, and so on. If you ask them whole numbers, they would say 0, 1, 2, 3, and so on. So if we see here the question, the collection of all the months of a year beginning with letter J. If you ask anyone, everyone would say January, June, and July. Since everyone will give the same answer, it is considered as a set. Second one, the collection of 10 most talented writers of India. If you ask everyone or anyone in India, everyone would have different opinions on who is talented. So second one is not considered a set. Next, a team of 11 best cricket batsmen of the world. When you ask anyone, everyone would have a different opinion on who is the best cricket batsman or a team of 11 best batsmen. So even this is not considered as a set. Now, the collection of all boys in your class. If you ask anyone in your class, everyone would give the same answer as the names of the boys in your class. So this is considered as set. Next, last one. The collection of all even integers. If you ask anyone, everyone would say the collection of even integers start with 2, 4, 6, 8, and so on. So this also is considered as set. So group of observations is defined as a set when everyone gives the same answer. The collection of months in a year beginning with J, everyone would say January, June, and July. But everyone would have a different opinion on who is the best batsman in the world or who is the most talented writer in India. While in your class, if you ask anyone, they would give the same names of the boys in your class. And if you ask anyone in the world of the collection of even integers, everyone would start with 2, 4, 6, 8, and so on. So it is also considered as set. So this is the second question of exercise 2.1. It says, if A is equal to 0, 2, 4, 6, B is equal to 3, 5, and 7, C is equal to P, Q, R, then fill the appropriate symbol belongs to or not belongs to in the fill in the blanks. So first point, what are these symbols belongs to and not belongs to? So this is symbol which we call as belongs to, and this one is not belongs to. To say if an element is a part of the set or not. So if we see here, if in the set A, we can see 0 is a part of set A. So we would say 0 is belongs to A, where 8 does not belong to A. So we would say 8 does not belong to A. 3 here does not belong to C, where P is present in the set C. Therefore, it belongs to C. 4 and 7. When we see set B here, it's a set of odd numbers starting from 3. So 4 does not belong to B, while 7 belongs to B. So belongs to, which means if the element is in the present in the set or not, and you said does not belong to when the element is not present in the set. Now the third question of exercise 2.1, it says express the following statement using symbols. So we have to use two symbols here, which are belongs to and does not belong to. So first one, the element x does not belong to x. So it does not belong to A. So we would write it as x does not belong to A. Second one, D is an element of the set B. So we would write it as D belongs to set B. Next, 1 belongs to the set of natural numbers. We would write it as 1 belongs to natural numbers. And last one, 8 does not belong to the set of prime numbers. 8 does not belong to the set of prime numbers. So this symbol is belongs to. We use this symbol when the element is present in the set, and this one is does not belong to or not belongs when the element is does not present in the set. Here x is belong does not belong to A, so we use not belongs to symbol. Where D is a part of B, so we used belongs to. 1 is a natural number, so we used belongs to symbol. And 8 is not a prime number, so we used does not belong to symbol. Question 4 of exercise 2.1, which says to state whether the following statements are true or false and to justify our answers. So, first statement we have here, it says 5 does not belong to set of prime numbers. We know that 5 is a prime number. So, first statement is false. Second statement, S is equal to 5, 6 and 7. That means 5, 6 and 7 belongs to S while they told 8 belongs to S. So definitely this is a false statement. Next, minus 5 does not belong to W, where W is the set of whole numbers. It is true. Whole numbers start from 0, 1 and so on. They told 5 does not belong to whole numbers. So this statement is absolutely true. Next one, we have 8 by 11 belongs to Z, where Z is set of integers. 8 by 11 is a rational number and not an integers. Integers belong only 0, 1 and positive infinity, and 0, minus 1, minus 2 to negative infinity. Therefore, 8 by 11 does not belong to integers. Therefore, this statement is also false. The fifth question of exercise 2.1, which asks us to write the following sets in roster form. So, first one we have here, it says b x x such that x is a natural number smaller than 6. So we would have b is equal to 1, 2, 3, 4 and 5. They told natural number smaller than 6, so we would write till 5 only. Next one, they said c x such that x is a two digit natural number such that sum of a digit is 8. So sum of digits is 8. We could start from 0, 0, 8. Sum of digits is 8, but they told two digit natural number. So we'd start from 17, 26, 44, 35, 71, 53, and 62. These are all the two digit. Okay, we have another one, 80. We also have 80. So two digit natural number such that sum of digits is 8. Next, third set, D x such that x is a prime number which is a divisor of 60. So we have only three divisors of 60 which are prime numbers. They are 2, 3 and 5. Next, finally fourth one, set E x such that x is an alphabet of beta. We would never repeat elements in a set, so we would get B, E, T, R. Have the sixth question of exercise 2.1, which says to write the following sets in set builder form. So the first one we have multiples of 3, so we would write it as x such that x is equal to 3n, where small n belongs to capital N, and n is less than or equal to 4. Next, second one we have powers of 2, 2 power 1, 2 square, 2 cube, 2 power 4, and 2 power 5. So we would write as x such that x is equal to 2 power n, where n belongs to natural numbers, and n is less than or equal to 5. Next, third one we have powers of 5. 5 power 1, 5 square, 5 cube, 5 power 4. So we write as x such that x is equal to 5 power n, where n belongs to natural numbers and n is less than or equal to 4. Next, last one, fourth one we have squares: 1 square, 2 square, 3 square, 4 square. So this one we would write it as x such that x is equal to n square, where n belongs to natural numbers and n is less than or equal to 10, because we have still 100. We have the seventh question of exercise 2.1, which says to write the following set builder form to rooster form. So first one we have here, it says x is a natural number greater than 50 but smaller than 100. We would write it as 51, 52, 53, and so on till 99. Next, second one, b, x is an integer where x square is equal to 4. So if x square is equal to 4, and if we root on both sides, we would get x is equal to plus or minus 2. So set b belong, sorry, plus 2 and minus 2. Third one, d, x such that x is a letter in the word loyal. So since we don't repeat in letters, we would get L, O, Y, and A. Next, last one, the fourth one we have E, such that x is equal to 2n square plus 1, where n belongs to minus 3 and n is between minus 3 and 3, and n belongs to integers. So we have x is equal to 2n square plus 1. If we put n is equal to minus 3 or plus 3, we would get 2 into 9 plus 1 is 18 plus 1 is equal to 19. If we put n is equal to minus 2 or plus 2, you get 2 into 4 plus 1, which is 8 plus 1 is equal to 9. If we put n is equal to minus 1 or plus 1, 2 into 1 plus 1, which is equal to 2 plus 1, which is equal to 3. And if we put n is equal to 0, 2 into 0 plus 1, which is equal to 1. So set E consists of 1, 3, 9, and 19. The eighth question of exercise 2.1, it's last one. So we have to match the roster form with the set builder form. So first one we have 1, 2, 3, 6. Second one we have 2 and 3 only. Next we have MATHEICS. Fourth one we have 1, 3, 5, 7, 9. So first only we can see MATHEICS would match with D, X such that X is a letter of the word mathematics. Next, 1, 3, 5, 7, 9 matches with B because X is an odd natural number smaller than 10. Next, 2 and 3 will match with C because, sorry, 2 and 3 will match with A because X is a prime number and a divisor of 6. And lastly, 1 would match with C since X is a natural number, not a prime number, and is a divisor of 6. So 1 would match with 6. So we would write this as 1 matching with C, 2 matching with A, 3 matching with D, and finally 4 matching with B. Hope you understood the questions of exercise 2.1. The playlists of different exercises of this chapter are given in the description down below. Go check out those and subscribe for more such videos of different exercises. Thank you.